All right, welcome to Worksheet 2, the answer video edition. Now you might be looking at this, you might be saying to yourself, this is not Worksheet 2. This is actually a warm-up I've done in the past. What is the area of a rectangle? Here are the measurements of the rectangle. We have 2.35, we have 10.11, and if it's area, we're multiplying length times width, and we get the area. And so our calculator, we take this number, oops, that's not laser mode. We take this number, we multiply it by that number in our calculator, blah, 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 right? Okay, cool. Now, when we round it though, we do need to consider the significant figures. So the first number has 3 significant figures, the second number has 4 significant figures. We're going to pick the weakest of these two. 3 sig figs is the lesser of the two. We're going to pick that one. So we only want to show 3 significant figures in our answer. Cool? So we round to 3 values, so 23.7. Everything after the 7 has to be rounded into the garbage can of math. And so that next number is a 5, and that's the only one really we actually consider is the very next number. The 5 gets rounded up, as they say, so the 7 becomes 8. And number 2, we're averaging 3 trials together. We just do standard averaging. We add these 3 numbers together, and then we divide by 3 because we're adding 3 numbers together. Now, when we do that, we do come back here and go, okay, this has 4 sig figs, 4 sig figs, 4 sig figs, so the average should still have 4 sig figs. Why don't we divide? We're dividing by 3. Isn't that 1 sig fig? Well, how many numbers are there? 1, 2, 3. There's exactly 3 numbers, so we know that's a fact. So we're dividing by exactly 3, which is infinite sig figs. So we're really limited by these measurements, not by the counted value of numbers. Okay, worksheet 2 has all of this dimensional analysis stuff on it. And we start with number 1, and the setup is already there. We start with kilometers, so they wrote the ratio between kilometers and meters. 1 kilometer is 1,000 meters. And then they wrote another ratio, 1 meter is 1,000 millimeters. And it's set up with the given right here. The given is right here. And then a ratio to convert kilometers to something. And they chose meters. And then that ratio to change meters to millimeters. And the way this would go is you have kilometers times meters over kilometers. So kilometers times meters over kilometers. The kilometers would cancel out. The meters wouldn't. And then you're taking the meter unit, M, and multiplying it by millimeters and dividing it by meters. So you have meters times millimeters divided by millimeters. And these two are going to cancel out. You're just left with millimeters. The last unit left is millimeters. And so these are all about setting them up so that the units cancel. After the units cancel, then we can throw in the numbers that make those statements true. Let's go with the second one because it wasn't filled in. But you have the first one up. How to do the math. Now that you have it set up, 0.75 times 1,000 divided by 1 because it's 1,000 over 1, so it's divided by 1. And then times 1,000 divided by 1. Okay? So 0.75 times 1,000 over 1 times 1,000 over 1. Now the second one, we had grams, we had kilograms, but the numbers weren't filled in. So we have to remember the relationship between kilograms and grams. Remember, a kilogram is a heavy, heavy thing. So 1 kilogram is heavy, but it takes 1,000 grams to equal it. So we're writing 1 kilogram and 1,000 grams on the bottom. Why is the grams on the bottom? Again, it's about the units canceling. The unit we were given was in grams, 6.5 grams, and the unit we're going to, kilograms, needs to be on the top and not canceled out. So the units work, then we do the math, 6.5 times 1, because that's on top, over 1,000, that's divided by 1,000. So 6.5 times 1 divided by 1,000, boom. Now what's nice, these setups, which are a little bit new to you, can then be tested by you kind of going like, King Henry died by 1, 2, 3. And you can kind of go do it in your calculator, get this number, and then kind of go, okay, I would move the decimal 1, 2, 3, and that number works also. I want to be clear, I'm grading the work. So this problem here would be worth like 3 points, and the answer is only one of those 3 points. So I need you to lock in, get focused on how the work is done. Let's go to number 3. We have the given already written down. It's millimeters. So we want to set the units up so that millimeters cancel. If it's on top, Then the unit millimeters needs to be on bottom in the next problem, change to meters. Meters is on the bottom, change to kilometers because we're looking for kilometers, so we're doing 2 steps here. So meters cancel to millimeters cancel to meters, meters cancel to kilometers. That unit doesn't cancel, so it's in the answer. Then we throw in the numbers and we calculate. Same thing here, we're given liters, so liters should go on the bottom and what we're hunting for should go on top. Then we fill in the relationship in math. Okay, take a look, practice these guys, practice these guys, practice these guys, all right? Then we're doing some significant figures in math at the same time. When we add numbers together, we think about where the decimal places end first. If we're multiplying or dividing, we look at where the sig figs end first, slightly different. So in number 7, 6.5, the 5 is the estimate, plus 8.101, the last one is the estimate. But the problem is 6.5, 6.5, that first decimal place is an estimate. So we have to stop and round when we hit the first decimal place, which is why it's 14.6. Similar problem in number 8, the first decimal place, 20.0, that 0 is the estimate. So we have to show the first 0, because that needs to be the estimate. If we just do 8 minus 12 and 20 minus 12 and write 8, it implies the 8 is the estimate and not the first decimal place. So we have to give them the first 0 there. Number 9 and 10, we're multiplying and dividing. Plop these into our calculator, it spits out an answer, and then we have to write down an answer with the correct sig figs. This might mean rounding like it does in number 9. We have 2 sig figs and 3 sig figs, so we show 2. And then number 10, we have 3 sig figs and 2 sig figs, so we have to make sure we sew 2, and that means putting that decimal down so that righty 0 is activated by the decimal point. So 11 and 12 and 13 and 14 are all adding and subtracting, so we let the calculator do the math and then we do the rounding. We do the rounding, we figure out where the decimal places end. Like in number 14, the decimal places, we have 2 decimal places and 1 decimal place in the 2 numbers, so we have to stop at the first decimal place. In number 13, we have 2 decimal places and 3 decimal places, that's 4, 3. So we're going to stop when we hit to the second decimal place. And number 12, we have 2 decimal places, 2 decimal places, 3 decimal places, 2 decimal places. Once we get to the second decimal place, we're going to stop. And then in number 11, we have 1 decimal place, no decimal places, and 2. So we're going to show no decimal places. My face is actually blocking the answer to number 15. That's weird. My face is not usually that in the way. So we're doing 2 sig figs times 3 sig figs. This is multiplying. So we're going to take that answer, and are we going to show 2 or 3 in the answer? That's right. Good job. We're going to show 2 because that's the lesser choice. We always pick the weaker of the choices. We're going to show 2 sig figs. So the answer that's hiding behind my face is 9.8. All right, let's go to number 5. Next slide 5. Multiplying. How many sig figs are in those 2 numbers? Those are lefties. Lefties never count. So we have 2 sig figs, 0, 0, 3, 6. That's 2 sig figs. And 0, 0, 2. That's 1 sig fig. So we're only going to show 1 sig fig. There's a lot of lefty zeros before we get to the 1 sig fig. And then we're dividing 2 sig figs by 2 sig figs. So we only show 2. 3 sig figs by 3 sig figs. So we only show 3. All right. So it turned out that the last couple questions were actually identical to the first couple questions, and sorry about that. So if you did the first set a second time, they're the same as the second set. I would practice dimensional analysis using things you're more common with, maybe feet to inches, maybe hours to minutes. Start with a number like 5 hours, write down 5 hours, try to figure out how many seconds that is. You can easily change 5 hours into minutes using the minutes to hours relationship, 1 and 60. And then you could do it again to seconds or go reverse. Let's see, someone has been counting for a long time and they've gotten to 50 million seconds. How many hours is that? So you'd start off by writing 50 million seconds. Try to write your first ratio. You're starting with seconds. Then seconds would go where in the first ratio? On the bottom, right? And then you could change it to minutes on the top. So to start with 50 million seconds, it'd be like 1 minute is 60 seconds. All right, that changes your seconds into minutes. But you want to do hours, so you need to add another ratio. Right now you have minutes over seconds, so the next ratio should have minutes on the bottom and hours on the top. And so your second ratio would have 1 hour on the top and 60 minutes on the bottom, and you convert it again. So you do it a couple steps. Start with the units, then add the numbers. Start with the units, then add the numbers. After all the numbers and all the units are set up properly, then you grab your calculator and start typing to find the answer. All right. Practice more, practice more. There's lots of good practice out on the wonderful, wonderful world of the internet. I feel like this red dot should be like right on my forehead, but I can't get it on my forehead. That's weird. All right. Anyway, guys, hope you're doing well. Talk to you later. Bye.